This is a process of glycolysis. We're taking an alpha glucose molecule and turning it into 2 pyruvate molecules. Throughout this whole process, we're going to be using 2 ATPs and we'll be producing 4 ATPs. So the first step of glycolysis is that we're taking an alpha glucose molecule and we're going to be changing it into a glucose 6-phosphate group. How we do that is through the process of attaching a phosphate group onto the 6H2OH. For the students who don't understand how this happens, here is a more detailed picture of it. We have 2 ATP that are freely floating, and they come over, and hexokinase, an enzyme, takes the ATP and breaks it down and turns it into ADP. So that phosphate group that's now free attaches itself to the CH2OH. H leaves, becomes an extra hydrogen in wherever, and then the phosphate is there. This is where we're changing glucose 6-phosphate into fructose 6-phosphate. How we're doing this is through the enzyme called phosphoglucose isomerase. So how it happens is, what's happening is that you're losing a structure and then it's becoming a stick. So this carbon here, instead of it being attached, it becomes disattached and these two connect. And that just comes and branches off like this. This is the same phosphor group. And phase 3 to phase 4 is a process of getting fructose 6-phosphate to fructose 1,6-phosphate. An ATP comes, and then we use this enzyme to break a phosphate group off of the ATP, then that ATP becomes ADP, and then that phosphate group attaches itself to that CHO2H, and that becomes another phosphate group. Therefore, we have a 1,6-phosphate group. 1,6-phosphate group. So step 4 to step 5 is to get fructose 1,6-biphosphate into GAP and DHAP. This happens through the enzyme aldolase. So basically what's going on is that this enzyme breaks down the carbon or the fructose molecule into 3 carbon molecules with the phosphate group attached to them. And now, since notice how they're both on opposite sides, we do not want DHAP, we want GAP, but that happens in the next step. For phase 5 to phase 6 is the process of getting GAP and DHAP into 1,3-diphosphoglycerate. So first what we need to do is we have to flip that DHAP because the opposite, like when they're opposite, it's not good. So it's converted by triosphosphate isomerase. So after it's the same, then we have 2 NAD molecules coming in. 2 NAD because there's two molecules split up. It comes in, takes the hydrogens off the carbon, becomes 2 NADH positive, and then so 2 NADH plus 2H plus, and then you get 2 freely floating phosphate groups. They attach where those hydrogens originally were, and then that becomes 1,3-diphosphoglycerate.
Step 6 to Step 7 involve taking 1,3-diphosphoglycerate and converting it into 3-phosphoglycerate.
So how this
works is through 2 ADP coming along and changing to 2 ATP through the phosphoglycerate kinase enzyme. The phosphate groups that are attached to the ends of the carbon molecules are left and they become 2 ATP rather than 2 AD. We are still left with the phosphate groups attached to the carbon molecules.
Okay, I'm videoing.
Steps 7 to 8 require taking 3-phosphoglycerate and converting it into 2-phosphoglycerate.
So
this happens through the enzyme phosphoglucomutase.
Okay, we're gonna write it over. Anyway, how to get that?
So all in all, what this step is doing is it's taking the phosphate group from the 3rd carbon and converting it and placing it into the 2nd carbon.
From the 3rd carbon, and it just transfers it over to the 2nd carbon. Okay, I'm recording.
Steps 8 to 9 take the 2-phosphoglycerate and change it into phosphophenylpyruvate. This happens to the enzyme analase. So what's happening is that a hydroxyl group and a hydrogen group is removed off of the molecule. This happens twice, so therefore 2 H2O or 2 water molecules are removed.
Okay, I'm going.
Steps 9 to 10 take phosphophenylpyruvate and convert it into pyruvate. This happens through the enzyme pyruvate kinase. As you can see, the two red dots in the middle of the carbon molecules represent the phosphate group. Pyruvate kinase will come and take the phosphate group off of the molecules. 2-ADP will come along and take that freely floating phosphate group and attach it to itself, creating 2-ATP.
There's two because there's two
Thus,
molecules.
in the end result, we have pyruvate.
It's not working.